The book calls this reducing before you multiply. The book calls this reducing before you multiply. Back in the day, when I was just a young top there, we called this, and I'll refer to it as this, cross-canceling.
Oh, yeah.
I'm sure if you took some of your homework home, your parents probably said, well, why don't you just cross-cancel that? And you would have said, I don't know what that means. Because we ain't covered it yet. Well, today we'll cover it, and then you won't have to use that excuse no more. And here's the deal. If you multiply these two fractions together, right here, 5/6 times 1/5. And this is an easy one. 5/6 times 1/5. If you multiply those two fractions together, this is how we normally do this. We multiply across, and 5 times 1 equals 5, and 6 times 5 equals 30, and then you reduce it. 5 goes into both of them, and you end up with 1/6. Okay, that's how we've been doing this here. But when you multiply fractions together, you can save yourself a lot of time, a lot of work, a lot of headache, especially when the numbers get a lot bigger, by cross-canceling. And all cross-canceling is this. You are looking for top numbers and bottom numbers that can be divided by the same number. And then you are crossing them out, or reducing, I guess would be the best way to do it. And I'll show you, a picture's worth 1,000 words here. In the case of 5/6 times 1/5, and it's only tops with bottoms. You can't do top with another top number. It has to be a top with a bottom number. If you look here, I see that I have 2 5s. Okay, and 2 5s have the same factor. What number goes into 5 and 5? 5. If you saw the fraction 5 over 5, you'd say, well, I can divide those both by 5. And that's what you do here. If you see two numbers that another same number goes into, you can say, okay, 5 goes into 5. You don't really have to write the divided by 1 time, and 5 goes into this 5 1 time. Now, if there was a 2 over here, I could do it with the 6, but there's not. Once you do that, and you can't cross-cancel anymore, then you multiply across like it is, and you get 1 times 1 is 1, and 6 times 1 is 6. And you don't have to, if you cross-cancel all that you can right away, you won't have to reduce the fraction that you get when you multiply it over there. We'll do a lot of examples because I know most of you are going, well, I don't understand it. Take a look at this one. 1 1/5 times 1 1/9. 1 1/5 times 1 1/9. Well, as always, the first thing we do is make these improper. So when I do that, what do I end up with? 5 times 1 plus 1, I get 6/5 times 1 times 9 plus 1, 10/9. Now, if I were to multiply it like it is, I'm going to get 60 over 45, and then I got a lot of work to do because I'm going to have to reduce and do whatever. But before you multiply, look to see what numbers can cross-cancel. What common factors? For example, what number will go into 6 and 9? Holly? 3. So you do that. You just say to yourself, okay, if I divide 9 by 3, and you don't have to write this down, but I will for now, I get 3. If I divide 6 by 3, I get 2. So these two cross off, and instead of having a 6 and a 9, now you have a 2 and a 3. What about 5 and 10? What number goes into 5 and 10, Zach?
1/2. Well, 2.
What number goes into 5 and 10? Colton? 5. So I divide 5 by this. Were you giving me the answers here? 5 goes into 5 once. 5 goes into 10 twice. Okay, nothing else will cross cancel. Now you multiply across, you're left with a 2 times a 2, which is a 4, and a 1 times a 3, which is a 3. 4/3, you'd still have to simplify it, because this doesn't change that, it's 1 1/3, but you don't have to work with a number like 60 over 45 to try to get to this. It's gonna save you scads of time doing it like that. In reality, you know what it really is? In reality, it's prime factorizing like you did before. Let me show you. We started off with 6 times 5 times 10 over 9. In reality, what you're doing is this. What are the prime factors of 6? 2 times 3, right? What are the prime factors of 10? 2 times 5, correct? That's my top because I'm multiplying all that together. What are the prime factors of 5? It only has 1. Prime factors of 9 are 3 and 3. In reality, it's doing this, and you're just crossing off like numbers. And look, you'd end up with 4 over 3. But you don't have to go through all of that work. It's just looking at it and going, oh, what can I divide this by? What can I divide this by? Okay. And you can do top with the bottom. It could be actually over itself. You could still do it. It's like reducing a fraction anyway. Josh?
The thing that you have to cancel it out with, it has to be the smallest number, right?
I don't know what that means.
Like if there's, like Zach said, for 10 and,
Yeah, you couldn't take a 10 out of 5.
yeah,
Yeah, that's the biggest you could take is this. But notice in this one, we took a 3 out of them. Neither one of them were a 3, but you could take a 3 out. Let me give you like a hypothetically big. You know, what if I had 45 over 60 times, 20 over 15. And I look at those, and if you multiply all that out, you're going to get 900 over something, whatever thing there. What can I cross cancel? And you can cross cancel as many times as you can. Ava Wyrick, what can I cross cancel?
You divide 15, or you do 15, 45 by 15, like.
How many times does 15 go into 45?
3 times.
3 times. So you could say, okay, 15 divided by 15 is 1, 45 divided by 15 is 3. And those are the new numbers you can use. What else could I do there? Colton? 20 goes into 20 once, and 20 goes into 60 3 times. What else? Like I said, you can do these two too as well. They can be right over top of each other. Alex?
3 goes in 3 now.
And 3 goes into 3. And by the time all the smoke clears, you end up with 1 times 1 over 1, which is just 1. And you don't have to do this times this and that times that and try to reduce it from wherever it is there. Now, can you do this with division? Yes or no? 5/6 divided by 5/2. This only works when it is multiplication. Okay? But the nice thing is, a division problem becomes a multiplication problem when? Alex?
You have a fraction or
When you change this, okay, I can't cross cancel anything right now. Even if something looked like it could, you could. You can never cross cancel until it becomes a multiplication problem. So you need to change this into 5/6 times, flip this fraction over 2/5. And when you do that, what crosses off? Charlie? Yep, both of the 5's cross off because they go into each other once. What about the 2 and the 6, Colton? 2 goes into 2. 2 goes into 6. 3 times. What am I left with then? 1 times 1 is 1. And 3 times 1 is 3. So that whole thing ends up being 1/3. Okay, now do you have to cross cancel? No, you don't. You can still do the problem the other way, but I can tell you later on when you get to 7th grade, if you're not doing it now and don't do it then, you're going to find yourself in a very, 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 very whatever thing. Let me give you one to do. 3 1/3 times 2 1/4. 3 1/3 times 2 1/4. Do that problem for me, if you would. Again, you can't cross cancel till you make them improper. Don't even think about it until you make them improper. Did we get an answer yet? Hopefully you got that as your improper fractions, 10/3 times 9/4. And then hopefully you saw that 3 goes into 3 and into 9, 3 goes into 3 one time, 3 goes into 9 3 times. What else goes into what? Ava?
10 goes into 2 5 times, and 4 goes into 2.
Okay, so everything cross canceled down to that. Nothing else can go into anything, so you end up with 15/2, which when you change it back to a mixed number is 7 1/2. How many folks out there got 7 1/2?
But I didn't do this.